Oh, can you hear me?
Hello, Professor. Can you hear me? I hope you can hear me clearly.
Yes, I can hear you. Yes, yes.
I'm sorry. It was really heavy workload in my office today, and I returned home a few hours ago. I'm sorry for the delay.
It's okay. Yeah, yeah, it's
Uh,
okay. Shall
s-
we get started?
yes, Professor. So
Okay.
we were discussing about topics in LLMs in education. So in our last discussion, we basically reviewed two of the papers, and then I read a couple of papers and I made a presentation. So if I get your permission, I wanna share my screen with you.
Sure, sure. Yeah.
Yes, please. So just tell me you can see my screen or not.
Okay.
Uh, can you see my screen?
Yeah, I can say that. Yes.
Yeah. So in the initial paper, in the first of the paper, I basically read one of the paper that was related to a comprehensive survey on deep learning techniques. So let's begin with one of the core questions: why deep learning in education? So in recent years, education has gone through, there are so many digitalization. There are like notes, learning management systems, different mobile apps, different platforms are used. So the data sets or the volumes, the huge volume of data are used, like quiz answers, time on task, click behavior, video views. So most of the time traditional machine learning struggle because it relied on manual feature engineering. So someone had to decide which data to use. So in this particular field, deep learning can play a vital role. So because most of the model can automatically learn patterns from raw data, it can handle sequences like learning timelines and understand complex relationships. So in this particular paper, they used, basically the goal of this particular paper is to explore how can deep learning be applied to improve education. There is a term called EDL, educational data mining. So how can deep learning be applied to this particular field? So there's so many data sets, so many models, and some of the future opportunities are discussed in this particular paper.
Mm-hmm.
So there's some code techniques they used. As you know that most of the machine learning types or deep learning in education, they classified them in three main sectors. Like there is a term called supervised learning in machine learning. So the models can learn from the label data. So like whether it's correct or wrong answers. Some of the examples like CNN, RNN, and GNN. There's another term called unsupervised learning. So there's so many unlabeled data sets, huge data sets, and the models try to find patterns from those data sets. Some of the examples are autoencoders and reinforcement learning. Basically, the models can learn from the environment. It is just one kind of reward-based system. So this was discussed in this particular paper. And you can see on the right side diagram that when the student does an exercise at time t, and the model encodes the exercise and results, and it updates the knowledge state, and it then predicts how likely the student is to get next exercise right. So this is one typical example of RNN structure that was collected from the paper. There is a term called knowledge tracing. I would like to discuss more about this term. So now we can basically talk something about what is knowledge tracing. So the main goal of knowledge tracing is to predict whether a student knows a concept based on their learning history. So it could be their previous learning skill or anything else. So there is a figure in this particular paper mentioned. So you can see that basically it shows how knowledge tracing schema really works. So you can see that there are some sort of exercises that are tagged with concepts. So you can see some calculus, there are some derivatives, some metrics. So these are some of the exercises. So correct answer basically strengthen a student's knowledge score. So if it can provide a wrong answer, it obviously reduce it, and over the time the models learns what the students likely knows. So this is one kind of typical example of knowledge trace. And the term that was used in this particular paper is student behavior detection. So basically it determines whether a student is paying attention to particular topics. Are they about to drop out? Are they cheating? So in the figure 4 we can see, and there is a model called APGCN model structure. It combines CNN for image video data. There is a term called graph convolution network for spatial relationships, and there are so many attention layers you can see to focus on important parts. So these models basically help platforms to identify risk early. For example, a model might detect whether a student is engaging with rust testers or some suspicious behavior patterns. It can detect. Some of the models are used. So another term that the paper introduces is called performance prediction. So most of the time it really answers it answers questions like will the student pass the course, what grade will they get in the final examination, something like that. So it basically try to predict their scores or course success. So it focuses on, we can say, overall outcomes rather than a specific knowledge points. In terms of knowledge tracing, as we saw earlier, we saw that it focuses on a specific knowledge point, but it focuses on the overall outcomes of the students. And so another term was used as personalized recommendation. So these sections basically explore how deep learning helps recommend personalized content. Like there's so many courses available online, there's so many courses available on YouTube, Netflix. So it basically tries to recommend which course is best suitable for which person. Some of the models are used, a lot of things that discussed in this particular paper, how these models are used, how these are managed. As you can see that in the figure, there are some user and course data are modeled initially, and then deep learning algorithms basically try to learn some preferences, and it provides some sort of feedback or recommendation that improve over the time. So basically in personalized recommendation, as I already said, it try to for example, I can mention if a student learns math slowly, but he may enjoy watching YouTube or watching videos. So this kind of system can recommend, for example, we can recommend Khan Academy for learning, rather than providing textual information. It can provide video information. So this is one kind of typical example of personalized recommendation system. This paper particularly describes a whole lot of things in datasets, challenges, so many future aspects or future directions where we can improve, like some of the datasets that used. These are widely used datasets, and some of the challenges, like it provides most of the educational data quality they're noisy, they are incomplete. There is a term called fairness and bias. So models might reflect social inequality. Another paper that I will discuss later on about bias, and then there's some sort of privacy concerns that was discussed in this particular paper. Some of the future directions, like teachers want to understand how models work using explainable AI. Different LLMs can be used, like tutoring or summarizing, and it inspired us to make the models used in multimodal settings, like combining videos, audio, speech, text, and educational platforms. So every other paper, the main motivation of this paper is that it was basically essay grading. Like essay grading is basically slow, basically subjective or hard to scale. Like in traditional automated scoring systems or AES, that only focus on surface level features like grammar or word count. That means that they often miss the actual meaning or quality of the ideas in writing. So large language models like GPT, we have tools that can understand most of the semantics, context, structure, and tone. So just like what human can do. So instead of replacing human graders, the authors really proposed a new version of evaluating essays that is called LLM-based augmentation. So in this particular proposal, the authors tried to propose a model that can help both students and teachers with scoring, feedback, and suggestion. So basically, most of the conventional automated essay grading systems uses some sort of, they just do grammar count, word count. There is no explanation of feedback, and it doesn't adapt in different writing styles. And so there is a term called, the author introduces a new version of LLM-driven augmentation. So it combines scoring, feedback, and interaction, and it acts as a tutor and supports student-focused revision. So in this particular figure, this shows the main idea of the paper. This is called LLM Augmented Essay Scoring, or LES. On the left side, you can see that traditional system just use automation to give you a score based on surface feature, as I have already discussed. But this paper proposed an augmentation technique where even a new evaluator or a novice evaluator with support with LLM, he or she can be an expert evaluator. So it basically provides a pretty good idea of using automated essay scoring in this particular field.
So
yes,
what's the, can you go to your previous slides?
yes.
What's the technical contribution of this paper? It seems like they only use LLM, so combine LLM with a no voice evaluator. So it seems like that's the only contribution. What is the evaluator here? So what is the no voice evaluator?
So that means that most of the yes, there is a the paper was based on Chinese student basically, and there's authors tried to say that there's a huge number of students there, and one or two particular instructor, they have to evaluate so many things, all those things. So it is really hard for a novice evaluator or a teacher to evaluate this properly. So the author tried to implement a system where an evaluator and an LLM evaluator, combining both together, they can provide a more comprehensive view of evaluating the essays.
Okay, so how do they do that? Like, do they use few short in context learning, or do they fine tuning the language models? So how? Yeah, go ahead.
So I found that they use in GPT 3.5, they use fine-tuned on datasets, and another time in GPT 4 that they tested in both zero shot and few shot settings.
Okay, zero shot and a few shot. So which means there are several examples from the human evaluator, and then they try to use GPT, right? So use GPT to simulate the behavior of the human evaluator.
Yes, Professor. And they even provide a new way. Like there is a term called quick, that means quadratic with kappa scores. They mention this is a metric, so they try to evaluate with this particular metric to score the essay also. Maybe you
Okay.
can discuss it
Okay.
on.
Okay. So which conference newspaper published at?
Because I have to look at this. I just forget it. I need to look at it again. Yeah. Look at the specific which conference the paper is published. I forgot it.
Okay.
I'm sorry for that. I just need to look at it.
Yeah, it's okay. Yeah, we can go ahead. Yeah, let's go ahead. I think the contribution of this paper is not enough. Yeah, I don't think it can publish at a very good conference. Yeah, we can go ahead.
So basically, they basically try to focus on 5 core tasks like scoring, explaining, error detection, revision, and interactive chat feedbacks. So some of the previous already available dataset they used, the model basically compared using GPT 3.5 and 4. So in 3.5 they use fine-tuned on datasets, and GPT-4 they tested on both zero-shot and few-shot setting. So a comparison using quadratic weighted kappa scores they mentioned in this particular paper. You can see on the table. So here is the main work of this particular paper, basically how they try to explain this. So they try to split the whole things in 5 sections. Like in task 1 and task 2, they basically focus on scoring the essay using a term called rubric, and then generating explanation for their scores. So there is a term called rubric. It is a detailed set of criteria used to assess writing, like clarity, grammar structure, it could be content relevance. So here I try to display how it really works. So initially the LLM reads the prompt and student essay, and combining all those things they try to, and another term is called scoring rubric. So basically initially there is 3 terms, and then it try to predict a score similar to what human can do, and then it basically provides a justification, like breaking down the strength, weaknesses. There are so many traits across different traits like content, grammar, coherence, and sentence variety. So, and then they basically aligned with aligned with quadratic weighted kappa. They basically try to provide them score. So this is very different from traditional AS systems. And then in the 3rd and 4th phase, they basically 3rd phase was used for error detection basically. So for example, GPT-4 is given an essay and asked to find issues such as there are some flags, grammatical errors, or redundant phrasing, awkward sentence structures, different logic issues. And then in 4th section they basically try to revision the suggestions. So it doesn't just point out mistakes, it suggests how to fix them. For example, there was an example that mentioned in this particular paper is instead of just the students is handwriting, they try to say that the student is handwriting. So this type of particular revision has done. So basically these suggestions are evaluated using there is a term called feedback precision. So using the feedback precision they try to answer like did GPT's comment accurately target a real issue, and another term is called usefulness. So would the suggestion actually help improve the essay? So evaluated using these two matrices like feedback, precision, and usefulness. And basically in fifth step there is a called conversational feedback. So here they try to just receive, instead of just receiving a static score, so a student can answer questions like, for example, student can answer questions like, why did I get a 3 for organization? So it explains weaknesses for the students, like your body paragraphs are not clearly connected to your thesis. So this is called basically a multi-turn interaction, a conversation between the students and AI. So it helps students basically build metacognitive writing. Metacognitive writing is the ability to think about how they write and how they improve. And this is the way basically they try to evaluate all these things in this particular paper.
Mm-hmm.
So how well did the LLM augmented essay scoring actually work? Firstly, I found that GPT-4 consistently outperformed fine-tuned GPT 3.5 across all 5 tasks, and using quadratic weighted kappa, this is a unique measurement they use in this particular paper. GPT 4 reached values as high, most of the time they are high, and they are most of the time accurate and useful feedback across different traits, like they use grammar, coherence, they use content, and what's more important is that GPT-4 suggestion helps students revise and improve their drafts, not just see it great. And some of the limitations that was mentioned in this particular paper: first, most of the LLM can hallucinate or misidentify errors. Secondly, there's the issue of bias, because LLMs are trained in massive web data, so there is an issue of could be an issue of bias. There is an issue of students becoming over-reliant on AI suggestions. So the authors recommend that these systems be used with human-in-loop supervision, and that's the main reason why they not only fully heavily dependent on LLM, rather than they are trying to combine with human evaluator and LLM to be focused on this particular task. Some of the future work that's mentioned to improve the work. Like their peer review feedback, they mentioned that if you can implement peer review feedback, it will enhance the model or enhance our framework to work better. Integrating LLMs into writing dashboards that can track learning over time, and fine-tuning LLMs to align with specific school curriculum or rubric. And lastly, last paper, that was, I found that most of the time, almost all of the authors, they talk about bias. So I was searching for a paper related to improving some techniques in bias reduction in this particular field. So I read this. I found very interesting paper, large language model LLM bias index, LLMBI. So in this particular paper, basically, so as we know that most of the LLMs.
Can you finish it? Can you finish it in 8 minutes? Finish it. Yeah, finish the slides in 8 minutes.
Yes. I just need 2 or 3 minutes just to talk. Yeah.
Okay.
So as we know that most of the LLMs are trained on huge data set, so they basically try to implement a new framework called LLM bias, and here you can see the main thing of LLM bias. They basically try to implement a framework called LLMBI. So basically using FI, this formula, they try to measure bias across 9 dimensions like gender, race, and other things. And
so why why do they use data formula to measure the bias? Can you go to previous slides? Yeah.
Yes,
So
yes,
here they
please.
have LMBI, right? So why do they use this metric? Uh I don't think this metric can actually measure the bias. So what's the idea behind it?
Yeah. So, Professor, there is a term called, you can see that LLMBA. It basically can predict a score based on different things. Like if the training data set lacks diversity, it adds a penalty. Uh, it also adjusts for sentiment bias, uh, which may look at whether emotionally changed language is skewing the results or not. So here you can see that FI, which means that the weight of each bias type. There is a
Okay.
VI called bias. There is a bias score. They basically try to um, get a mathematical score from all those things,
Mhm.
so
Okay.
that they
Okay.
make better adjustments.
Okay. Can go to yeah. Go ahead. Go ahead. Move. We can go to the next
So
slides.
this diagram basically summarizes the pipeline used in this particular study. So initially we can see that it begins with the prompt generation. For example, prompts about gender, roles, region, or something else. Next, each response is annotated for bias. So this involves basically identifying subtle or explicit bias expressions. And from this point, you can see that after annotating the bias, there were three main directions, like bias scores for each dimension using detection algorithms. There is a term called diversity penalty if the training data lacks representations, and there is a term called sentiment bias. So there are so many tools are used like textbook or other things. And finally, all those components are combined using LLM by formula that I mentioned earlier to produce a single composite score.
Mhm.
So basically, LLMBA produce a pretty good result in using GPT-4. You can see. So after applying LLMBI, the result showed clear variation of bias across different topics. Like when we discuss the role of women in technology, it produced 0.88, which is very high. So, summarize the principles of there is a term in Buddhism. It got 0.82 scores. In economic impact of immigration in Canada, it provides 0.84. So it produced pretty good scores, according to the authors of this particular paper. Yeah. So thank you, Professor, for your time. I'm sorry it was a pretty long slide. Basically, the reason was that we didn't meet in last week, and this is the main reason why actually.
Okay. Yeah, thanks for the presentation. Yeah, overall, I think the presentation is good. So except that the two papers here is they don't contain too many technical depths. Yeah, so I think probably in the future we can choose some good paper, choose some good papers. So yeah, these two papers they are I think they are okay. Yeah, they are okay. And yeah, so next time we you can also like present some papers that you think are very interesting and very good, right? And then also like each time when you present the paper, right? So in the end of the presentation, you can think about based on this paper, like what kind of new things we can propose, right? So what, for example, what's the limitation of the paper, and based on this limitation, do we have some good ideas to improve it or solve those limitations? Yeah. So yeah. So those new ideas or our own ideas, that's will be very useful, right? So otherwise, if we only present the paper and then we don't have our own ideas, yeah, that's not very useful because, for example, after several weeks, like 2 or 3 weeks, we will totally forget the paper, right?
Yes, yes, Professor. Yeah. So thank you for
Yeah.
your suggestion, Professor. I'll obviously do the things accordingly.
Okay. Okay. Sure. 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 Yeah. And do you have any questions or wants to discuss with me like this week?
So what we can do, Professor, next week? What could be? Do you do the same things that we are doing currently, or
Yeah, 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 yeah. So basically, I think we need to discover more papers, read more papers.
yeah,
Yeah.
sure, Professor.
Okay. Okay.
So thank you
Yeah,
so
and
much, Professor,
hopefully,
for your time.
yeah, hopefully we can find some interesting topics and we can have one publication. Yeah, that would be the ideal uh, ideal results.
Yes,
Okay.
yes, Professor. So thank you
Yeah,
so
yeah,
much
yeah.
for your time, and hopefully we'll meet next week again.
Yeah, yeah. Thank you, thank you. Yeah. So see you next week.
See you, Professor. Have a good day.
Yeah. Bye bye.
Bye. Hold it.